Hi, welcome to the first analytical geometry tutorial. Today's tutorial is titled Basic Analytical Geometry, and we are going to be looking at 4 concepts pertinent to analytical geometry. First, we will run through coordinates. We will be looking at what a coordinate is. We'll then progress on to the gradient or the slope of a line or line segment. We'll then move on to the midpoint theorem and thereafter the distance formula. In terms of what you need to know, you need to be familiar with your grade 10 work on analytical geometry. It would also be helpful if you went through at least the first 2 functions tutorials. Let us begin by taking a look at coordinates. Coordinates denote a point on the Cartesian plane. You will remember that the Cartesian plane is your x and your y axis. The coordinates, written as such, have an x value and a y value, which pinpoint the exact location of any point on the Cartesian plane. Let us take a closer look at that. The first set of coordinates that we are going to draw in is point A, which is x is equal to 2, y is equal to 4. Let's go to that. X is equal to 2, that's over there. Y is equal to 1, 2, 3, 4. That means that point A is going to be over there. Let's just write it in as point A. In fact, that's the coordinates 2 and 4. The next set of coordinates B are the coordinates x is negative 1, y is 7. X is equal to negative 1. Remember, this is my x-axis, so negative 1. And y is equal to positive 7. 1, 2, 3, 4, 5, 6, 7. And negative 1 is going to be over there. And that's point B. In fact, let's just write it in. Point C is the coordinates negative 3, negative 5. X is negative 3, y is negative 5, x is negative 1, 2, 3, y is negative 1, 2, 3, 4, 5. So that means that the coordinates of C are over there, which is negative 3, negative 5. And the coordinates of D are x is 3, y is equal to also negative 5. So it's at negative 5, but x is equal to positive 3. That's over there, that's the point 3 and negative 5. Notice that all the coordinates I gave you fall in the 4 quadrants: quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now let us take a look at the gradient. The gradient, also referred to as the slope of a line, measures the angle of inclination between the horizontal plane and the line segment. Let us take a closer look at that. We are now going to look at the gradient or the slope of a line. Remember, the slope of the line is basically the angle of inclination. So let's go through a few definitions. Gradient is the same as the slope of a line, which is the same as the angle of inclination. Now, let's use that angle of inclination theory. Angle of inclination would be how many degrees is it from the horizontal. That's its angle of inclination, or its angle of slope. Whatever you want to call it, I want you to just think of this as basically a hill, and how high is the hill sloped. Basically, what is theta? Now, if we are looking at theta, let us think about this. Theta is an angle made by the line we're looking at and the horizontal. How would we get theta? Well, let's look at the information that we do have. If I make this a straight line down, rather dotted line down, that's going to be the x value of 6. And that there is going to be the x value of 3. That is going to be the y value of 2. Let's just continue with that. Look at that. It forms a right angle triangle. And that is going to be the y value 4. Now, theta. The only bits of information I have, think about it. Do I have the size of that line? Yes, I do. Isn't it going to be 4 minus 2? Isn't that one going to be 2 units? Because it's 4 minus 2. And that is going to be 3 units. Let's just leave that units out. That's going to be 3. The reason 3, because 6 minus 3. So that's the only 2 bits of information I have. Don't worry about hypotenuse and all of that for now. But those are the 2 bits of information I have. This side is opposite theta, and this side is adjacent or next to theta. What if I use 10 to get my angle of inclination? 10 theta in this case would equal 2 over 3, opposite over adjacent. But instead of saying 2, I'm going to say 4 minus 2, which is how I got to the 2. And instead of saying 3, I'm going to say 6 minus 3. Okay, let's take that one step further. Instead of saying 4, isn't that my second y value? And isn't that 2 my first y value? Isn't the 6 my second x value? And my 3 my first x value? So that means that tan of theta is equal to change in y over change in x, or rather y2 minus y1 over x2 minus x1. That, ladies and gentlemen, is exactly what the gradient is. Gradient m is equal to tan of theta. But instead of saying tan of theta, we've seen that tan of theta is y2 minus y1 over x2 minus x1. In this case, y2 minus y1 is going to give us 2, x2 minus x1 is 3. That means our gradient in this example is 2 over 3, positive 2 over 3. If it's going to be sloping the other direction, our gradient is going to be negative. This is a positive sloping gradient. Also, we can calculate the size of angle theta. All we have to do to find theta is equal to tan second function of 2 over 3, which you just need to use your calculator for. Theta is equal to tan second function 2 over 3, which means that theta is equal to 33.7 degrees, rounded off to 1 decimal place. I'm not too worried that you came to theta though. My big concern for this example is that you got to a gradient of 2 over 3. Now let us apply that to the previous example we did where we were looking at coordinates. Now, I'm going to choose a few line segments, and I'm going to get the coordinates of those line segments. The first one I'm going to do is I'm going to look at my gradient of AB.